Do you think this necklace is made of real silver, or do you think it's just a knockoff? Based off of physical observations, you can't really tell, but with our chem lab knowledge, we can. With only a couple of styrofoam cups and a thermometer, we can conduct a calorimetry experiment to find out the specific heat of this metal and compare with the specific heat of silver to find out whether or not this really is made of silver. So I'm going to walk y'all through how to do that. Let's go. Chemists can identify substance on the basis of their chemical and physical properties, and the physical property that we're going to be measuring today is specific heat. Specific heat is the amount of energy that's measured in joules that is needed to raise the temperature of 1 gram of the substance to 1 degree Celsius. To measure specific heat in the lab, we can use a calorimeter, like the picture shown below. A calorimeter is a well-insulated container that can measure energy changes. The calorimeter is insulated to reduce the loss or gain of energy to and from the surroundings. Energy always flows from an object at a higher temperature to an object at a lower temperature. The heat gained by the cooler substance equals the heat lost by the warmer substance, so we can assume that no loss of heat has gone to the surrounding environment. In this experiment, we're going to try to find the specific heat of the necklace and compare it with the accepted literature value for the specific heat of silver. The necklace will be heated to a high temperature and placed inside the calorimeter containing a known quantity of water at a lower temperature. Having measured the mass of the water in the calorimeter, the temperature changed by the water, and knowing the specific heat of the water, which is 4.184, we can measure the heat change by the water in the following equation, where Q equals MCAT. Furthermore, we can find the specific heat of the substance by dividing the heat gained by the water divided by the mass of the necklace and multiplying that by the temperature change in the necklace. After completing all my calculations, I found the specific heat of my necklace to be 0.895, which is closer to the specific heat of aluminum, which is 0.903, than it is for the specific heat of silver, which is 0.235. So unfortunately, I got ripped off. This is more likely to be aluminum than it is to be silver. However, there are some experimental errors that could attribute for these differences, and the number one reason being that this necklace is an alloy or a combination of multiple metals, which means that the specific heat may not perfectly align with that of any one specific element. And another possible experimental error could be that heat escaped from our apparatus through crevices inside our coffee cups. And the number one trick that we can avoid this is to simply close off any junctions. And this just means using a lid or closing off the gap between where the temperature probe has to enter inside the coffee cup.